Welcome to the deep dive. Now, as someone who's, already deep in prompt engineering, you're probably pretty skilled at crafting instructions for AI.
Definitely. You've likely got your own techniques down pat.
Exactly. But what if I told you there's this really disciplined framework, something designed to take an AI from just being a useful tool to being more like a truly autonomous and, well, reliable senior engineer, especially for complex stuff like coding?
Okay, now you're talking. That's precisely what we're getting into today. We're doing a deep dive into something called Cursor AI prompting rules.
Cursor AI prompting rules. Got it.
Yeah, and this isn't just about, tweaking a single prompt here or there. It's way more structured. It's sourced from this really detailed GitHub Gist.
Ah, okay, so it's like a whole system.
Exactly. Think of it like a full operational doctrine plus a set of playbooks, all engineered to optimize how you interact with the AI for consistent, self-checking, and always improving behavior.
Okay, so our mission today is basically to unpack this whole thing. The core ideas, the templates, the built-in safety nets.
That's the plan. We'll explore how these rules make sure the AI is safe, efficient, and actually learns, giving you a kind of shortcut to understanding how to really empower an AI agent with discipline.
Sounds fascinating. So where do we start? What's the foundation?
Right at the heart of it is the cursor operational doctrine. It's laid out in a file, core.md.
The doctrine, okay.
Yeah, and this isn't just, helpful hints. It encodes the agent's always-on principles, its core operating system, you could say.
Always on principles. I like that. What kind of principles are we talking about?
Well, things like reconnaissance before acting, always preferring empirical validation over just guessing.
Okay, data over assumptions. Makes sense.
Strict command execution hygiene, we'll get into what that means, and something they call zero assumption stewardship.
Zero assumption stewardship. Intriguing. So how does this doctrine actually get, installed or applied?
Good question. There are two main ways. You can make it project-specific. You just create a .cursor rules file in the root of your code repository.
The repo.
Yep, and paste the whole doctrine content in there. Or if you wanted to apply more broadly across different projects, you can paste it into the global cursor settings.
That's flexible.
But here's the crucial bit. The instructions are very clear. Never edit these rule files bit by bit.
No piecemeal changes.
Nope. You always replace the full contents if you need to update it. This stops any drift from the core principles, keeps the AI's understanding consistent.
That makes total sense. Keeps it clean. So with the doctrine in place, what's the very first thing the AI does? You mentioned reconnaissance.
Exactly. The first key principle is reconnaissance and cognitive cartography. It's section 0 in that core.md file.
Cognitive cartography. Sounds fancy.
It kind of is, but it's super practical. It's a mandatory first step, non-destructive, so it doesn't change anything yet. And it happens before any planning or code changes. The AI absolutely must build what they call a high-fidelity mental model of the current environment.
A mental model. So it's like looking around the room before you start moving furniture.
Precisely. It stops the AI from just jumping in based on assumptions. It forces it to operate from ground truth, from actual evidence about the project. It's about building this foundational understanding.
Okay, so how does it build this model? What's it actually looking at?
It's pretty systematic. It inventories the repo languages, frameworks. It maps out dependencies, checks configuration files.
A whole setup.
Yeah, and also idiomatic patterns in the existing code, how things are usually done in this project. It checks the execution environment, finds the quality gates like test and linters.
Quality gates, right.
And even looks for chronic pain signatures, basically. Recurring problems may be found in issue trackers or logs.
Wow, that's thorough.
It is. And the output of all this, a concise reconnaissance digest, no more than 200 lines, just enough to anchor all the later decisions.
So that digest becomes a starting point. It prevents that speculative reasoning you mentioned.
Exactly. It ensures the AI works from a solid evidence-based foundation, just like, a good human engineer would do their homework first.
Okay, that initial deep understanding is clearly vital. What about its overall philosophy? The framework mentions an epistemic stance and operating ethos.
Right, that's section A. This really highlights the balance they're aiming for. Autonomous, yet safe.
Autonomous yet safe. The holy grail, maybe.
Maybe. It emphasizes that zero assumption discipline, again, privileging empiricism, what it can actually see in the files, or get from commands over just guessing.
Makes sense.
And there's also this concept of proactive stewardship. The AI isn't just supposed to fix the bug you asked about. It should also proactively look for and surface, maybe even fix underlying issues.
So improving things beyond the immediate task, like reliability or maintainability.
Exactly. It's about taking ownership, looking for latent problems in performance, security, you name it.
That's a big step up from just following orders. But if it's autonomous, it also needs to know when not to be, right? When to ask for help.
Absolutely crucial. And that brings us to section B, the clarification threshold.
Ah, the asking for help rule.
Pretty much. It defines precisely when the AI is allowed to consult the user. It doesn't just ask whenever it's slightly unsure.
Okay, so what are the conditions?
There are only 4 specific cases. 1, epistemic conflict, like if 2 authoritative sources, say 2 different config files, contradict each other.
Okay.
2, resource absence, maybe it needs credentials, or an API key that isn't there. 3, irreversible jeopardy, if an action could cause serious, non-rollbackable data loss or risk production stability.
Right, the really dangerous stuff.
Exactly. And 4, research saturation, basically. It's tried everything to figure something out, hit a dead end, and critical ambiguity still remains.
So unless it hits one of those 4 walls, it should try to proceed on its own.
That's the idea. It's a key guardrail. It lets the agent be autonomous without constantly bothering you, but ensures it escalates the truly critical issues.
That sounds like a huge relief for users, honestly. No more overly chatty or stubbornly silent AI.
Right. It strikes a balance.
So it's done its recon, it understands its ethos, it knows when to ask questions. How does the actual work get structured? You mentioned a feedback loop.
Yes. Section C describes the operational feedback loop. It's a clear cycle. Recon, plan, context, execute, verify, report.
Okay, walk me through that quickly. Recon is the mapping we talked about.
Right. Then plan is where it formalizes its strategy based on that recon digest. Context is about gathering anything else it needs, code snippets, specific file contents.
Got it. Execute is doing the work.
Yep. Applying the changes, usually incrementally. Then verify is crucial, rerunning tests, linters, checking the system state to confirm it worked, or spot issues.
And finally, report.
Report back to the user, summarizing what happened. It's this continuous cycle of acting, checking, and reporting.
It's very systematic. Now let's dig into that execute phase a bit more. There's something called the command execution canon in section 2. Sounds strict.
It is, and it's really interesting. It specifies exactly how the AI must run any shell command.
How so?
There's a mandatory wrapper. Every single command has to be executed inside the specific structure. Timeout 30's command 2-in-1 cat.
Okay, timeout 30's 2-in-1 cat. Break that down.
Sure. Timeout 30's obviously puts a 30-second limit on the command, preventing runaway processes.
All right.
2-in-1 redirects standard error, stredder, to standard output, start out. So both success messages and error messages go to the same place.
Oh, unified output.
Exactly. And then cat just ensures that unified stream is captured cleanly. The AI gets everything, errors and all, in one place for analysis. It prevents things from getting lost.
That's clever. A universal logging mechanism for every action.
Kind of, yeah. It guarantees visibility and stops things from running indefinitely.
Are there other rules for running commands?
Yes, a few important ones. It has to use non-interactive defaults whenever possible, flags like Migi or yes, to avoid getting stuck waiting for input.
Okay, assume yes.
Right. Also, chronometric coherence, which basically means setting a consistent time zone, like TZ Asia Jakarta in their example, so timestamps are consistent.
And consistency again.
And finally, fail-fast semantics. Using things like set-o or exit-o pipe fail in shell scripts, so if any command in a sequence fails, the whole operation stops immediately.
Prevents cascading failures. Makes perfect sense in an engineering context.
Absolutely. It adds a layer of robustness.
This level of detail really does feel like you're programming a disciplined engineer, not just prompting an LLM. Now, this doctrine isn't just a standalone theory, right? It works with operational playbook.
Exactly. The doctrine provides the core rules, and the playbooks are structured templates for putting those rules into action for specific types of tasks.
Templates for repeatable sessions.
Precisely. They're predefined structures. You, the user, copy the full text of a playbook template, maybe replace a placeholder line with your specific goal, and paste it into the chat.
Okay.
This kicks off an autonomous session that's already framed by the Doctrine's principles and follows a proven workflow for that kind of task.
So what are the main playbooks?
There are 3 key ones mentioned. Request.md is the general workhorse. You use it for building new features, refactoring existing code, making specific targeted changes.
Your standard development task, basically.
Right. Then there's refresh.md. This one's specifically for tackling a bug or issue that didn't get fixed on the first try.
Ah, for persistent problems.
Yeah. Using refresh.md triggers a more focused root cause analysis and then a fix attempt. It signals a deeper dive is needed.
Okay.
And the third one.
That's retro.md. You use this one to conclude a work session.
Like a retrospective meeting.
Sort of, but with the AI, it's used to harvest lessons learned from the session. And critically, it prompts the AI to suggest updates to its own rule files based on what happened. Wait, the AI suggests improvements to its own doctrine or rules based on the session?
Yes. That's the continuous improvement loop built right in. The retro.md playbook facilitates that self-improvement.
That's actually pretty cool. The AI helps refine its own operating manual.
It really is. And importantly, all these playbooks automatically embed the safeguards from the doctrine.
Like the reconnaissance step.
Exactly. The familiarization and mapping, that mandatory recon, is baked in. So is the command wrapper requirement. And also the rule against creating random Markdown files, notes, and summaries stay in the chat unless a specific file is requested.
Keeps the repo tidy. Okay, let's put it all together. Can you walk us through the flow of a typical session using one of these playbooks?
Sure. Let's say you use request.md. You paste it in, having replaced the placeholder with your goal, like add a new API endpoint for user profiles.
Okay.
Cursor AI then takes over. First, it does the reconnaissance inventories, the code, checks patterns, finds tests, and gives you that concise recon digest.
So I see its understanding first.
Right. Then, based on the digest in your request, it formulates a plan. It gathers any specific context it needs. Then it starts executing the changes, usually step by step.
Incrementally.
Yep. And after making changes, it runs the relevant tests, linters, whatever quality gates it found.
And if tests fail?
This is key. It attempts to auto-rectify the failures. It analyzes the errors and tries to fix its own code.
Self-correction. Nice.
Finally, it reports back to you in the chat. It'll use clear markers like a green check for success, a warning sign, or a construction sign if it's ongoing or hit a snag. It'll often include an inline TODO list for any remaining items. And critically, no stray files created.
So I get a clear summary of what it did, what worked, what didn't, what's next, all in the chat.
Precisely. Then you review that summary. You can ask for more iterations, or if the main goal is achieved, you might use retro.md to capture learnings.
And feed that back into the AI's rule set. Makes sense. Are there any key best practices emphasized for users working this way?
Yes, the source just highlights a few. First, be specific in that placeholder line. Don't just say, fix the bug, say what bug and maybe why it's important. State the what and why.
Clear instructions are still key.
Always. Second, one template per prompt. Don't try to mix a feature request and a bug fix in the same paste. Use request.md, then maybe refresh.md separately.
Keep sessions focused.
Third, and this might be hard for some, trust autonomy. Let the agent work. Intervene only if it hits that clarification threshold and asks you directly. Resist micromanaging.
Let it use its process. Okay, what else?
Fourth, inspect reports, not logs. The detailed reasoning, the errors, the diagnostics, that's all surfaced in the chat conversation. The actual rule files are meant to be concise. Don't go digging in unless necessary.
Focus on the chat output.
And finally, end with a retro. Regularly use retro.md to keep that rule set evolving and improving. It makes the AI better over time for your specific projects.
That continuous learning aspect seems really powerful. These rules sound solid, but let's talk about enforcement. How are the guarantees and guardrails actually implemented? What stops the AI from just ignoring them?
Good point. These aren't suggestions. They seem to be hard-coded constraints or checks within the cursor environment when these rules are active.
Okay, like built-in checks.
Yeah. So reconnaissance first is enforced. This system likely prevents file modifications until that F&M phase outputs its digest. The exact command wrapper is probably enforced by intercepting or monitoring shell execution.
Making sure it uses the timeout and output redirection.
Exactly. No unsolicited markdown means it likely monitors file creation and flags or prevents anything not explicitly requested or part of a planned change.
And deletions. You said safe deletions.
Right. The guardrail there is likely a check. Is this deletion happening under version control, like Git?
Oh.
And did the AI justify it clearly in the chat beforehand? If not, maybe the action is blocked or flagged.
So checks and balances. And the clarification threshold is just built into its core logic.
It seems so. It's programmed not to prompt the user unless one of those 4 specific conditions is met.
Okay, but what if something slips through? What if, say, it accidentally does create a random file it shouldn't have? Does it just leave it there?
This is a really telling detail about the discipline they're aiming for. If the agent accidentally violates the no new files rule, it has a specific protocol. It must immediately delete the mistakenly created file. Then it has to apologize in the chat for the violation.
Apologize.
Yes.
Ah.
And then provide an inline summary explaining what happened, why the file was created erroneously.
Wow. Okay, that's not just self-correction. That's like accountability. It acknowledges the mistake, fixes it, and explains.
Exactly. It builds trust. You see it policing itself according to the rules. It shows the discipline isn't just suggested, it's actively enforced, even by the AI itself.
That's impressive. Let's make this really concrete. Can you give a quick example scenario?
Sure. Let's use the example from the gist. Imagine you want to add a new API endpoint. Your prompt in the request.md template might be, add an endpoint that returns build metadata, commit hash, build time, use Go, update tests, and document the new route.
Okay, standard feature request.
You paste that into Cursor with the request.md structure. The AI kicks in. First, reconnaissance. It scans your Go project, identifies testing frameworks, API routing patterns, documentation conventions, produces the digest.
Okay.
Then plan. It decides where to add the code, what tests need updating, how to structure the documentation. Context.doc grabs relevant code snippets, execute, writes the Go code for the endpoint, modifies test files, adds documentation comments.
Using the command wrapper for any shell commands like running go build or something.
Absolutely. Then verify. It runs Go test, maybe runs a linter, let's say the test pass. Report, it posts a message in chat like, you'd added build metadata endpoint, updated unit tests, you'd documented route, maybe an inline TODO if something minor is left, no extra files created.
And all that happened autonomously after I just gave the initial request via the template.
That's the goal. You didn't have to tell it how to run tests or where to put the code or to remember documentation. The Doctrine and its reconnaissance phase guided those decisions.
The payoff seems clear. You're essentially empowering the AI to operate like that disciplined, autonomous senior engineer we talked about, planning, executing safely, checking its own work, and even learning.
Yeah, it really shifts the interaction. You're collaborating with a system that has its own rigorous methodology, not just giving step-by-step commands.
Okay, let's recap. We've journeyed through this really quite sophisticated framework, the Cursor AI prompting rules. It goes way beyond just writing good prompts.
Definitely. We've seen this operational doctrine, the always-on principles, combined with structured playbooks like request.md, refresh.md, and retro.md.
And core concepts like mandatory reconnaissance first, the strict command execution wrapper, the carefully defined clarification threshold.
Right. And the built-in self-correction and continuous learning through retrospectives. It all aims for predictable, reliable, and self-improving AI behavior, especially for complex technical work.
We've seen how these rules empower an AI to act, genuinely, like a disciplined, autonomous senior engineer. Now, for you listening, especially since you're already an expert in prompt engineering, this deep dive hopefully gives you a powerful blueprint, a new way to think about optimizing AI interactions for really high-level tasks.
It's a glimpse into a more structured, reliable future for AI collaboration, moving beyond simple Q&A or generation.
But it also sparks a final thought, something for you to maybe chew on. If we can define such clear operational doctrines, clarification thresholds, and continuous learning loops for our AI, how might applying a similar, really structured, almost rules-based mindset to our own work, our own complex problem-solving, project management, even learning, empower us to be more disciplined, more autonomous, and more self-improving?
That's a fascinating question. Applying that level of rigor and self-awareness to our own processes?
Something to think about. Thanks for joining us for this deep dive.